Alright, so in this problem, I have x to the power of x to the power of 3 is equal to 36. So I want to find the value of x here. So for my solution, I'm going to first start with x to the power of x to the power of 3 is equal to 36. Now what I'm going to do is I'm going to take the power of 3 on both sides. So now I have x to the power of x to the power of 3 to the power of 3 is equal to 36 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, right? And m and n here, these two are interchangeable, meaning this is also equal to a to the power of n times m. So if a to the power of m to the power of n is equal to a to the power of m times n, and a to the power of n times m is the same thing as a to the power of m times n, this means that this is also equal to a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, I have x to the power of x to the power of 3 to the power of 3 is equal to 36 to the power of 3. And I can think of x to the power of 3 here as m and 3 here as n. So if a to the power of m to the power of n is equal to a to the power of n to the power of m, then this means I can change the places of these two. So now I have x to the power of 3 to the power of x to the power of 3. And this is equal to 36 to the power of 3. Now 36 here, this is the same thing as 6 to the power of 2. So now I have x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 2 to the power of 3. And now again, remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 6 to the power of 2 to the power of 3, that's going to equal 6 to the power of 2 times 3, which is simply 6. So I have 6 to the power of 6. Now I'm going to, now if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, a is x to the power of 3, so I have x to the power of 3 to the power of x to the power of 3, a to the power of a is equal to b is 6, so 6 to the power of 6. So in this case, a is equal to b, so x to the power of 3 is equal to 6, meaning x is equal to the cube root of 6. Alright, so in this problem, I have x to the power of x is equal to 4 to the power of x plus 16. So the first thing I'm going to do is I'm going to take the ln, or natural log, on both sides. So now I have ln x to the power of x is equal to ln of 4 to the power of x plus 16. Now if I have something, if I take the ln of something in the form a to the power of b, and I can move this exponent b to the front. So this can equal b times ln a. So in this case, I have ln x to the power of x. I can move x to the front, and ln 4 to the power of x plus 16, I can move x plus 16 to the front. So now I have x times ln x is equal to x plus 16 times ln 4. Now if I distribute the ln 4, I get x times ln 4 plus 16 times ln 4. Now if I subtract x times ln 4 on both sides, these two cancel out, and I get x times ln x minus x times ln 4 is equal to 16 times ln 4. Now I can go ahead and factor out x from here, so I get x times ln x minus ln 4 is equal to 16 times ln 4. Now ln x minus ln 4, that's simply equal to ln x over 4. So I have this is equal to 16 times ln 4. And now This is essentially saying that x over 4 is equal to 4 over here. These two are equal to each other. So if x over 4 is equal to 4, this means that x is equal to 16, because these two have to match up as well. So now to check, let me plug this in over here. So if I plug in 16 over here, I get 16, because x over here, 16 times ln, 16 divided by 4 is 4. So I get 16 times ln 4 is equal to 16 times ln 4. So this works. Now for method 2, method 2 to check, I have x to the power of x equals 4 to the power of x plus 16. X equals 16, so I have 16 to the power of 16 is equal to 4 to the power of 32. 16 is 4 squared, so I have 4 squared to the power of 16 is equal to 4 to the power of 32, meaning 4 to the power of 32 is equal to 4 to the power of 32. Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now I'm going to rewrite x to the power of 6 here as x to the power of 3 times 2. So now I have this minus x to the power of 3 minus 2 is equal to 0. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, x to the power of 3 times 2, I can write as x to the power of 3 to the power of 2. Now this minus x to the power of 3 minus 2 is equal to 0. Now I'm going to let x to the power of 3 equal to the variable y. So now I have y to the power of 2 minus y minus 2 is equal to 0. So now to solve this, we're simply going to factor this. So I'm going to rewrite this as y squared minus 2y plus y minus 2 is equal to 0. And now I can factor by grouping. I'm going to factor these two together and these two together. So from y squared minus 2y, the greatest common factor is simply y. So I have y times y minus 2 plus, from y minus 2, the greatest common factor is simply 1. Now, if I factor out y minus 2, I get y minus 2 times y plus 1 is equal to 0. So this gives me two equations. Y minus 2 is equal to 0, and y plus 1 equals 0, meaning y is equal to 2, and y is equal to negative 1. So now recall how we let x to the power of 3 equal to y. So this means that x to the power of 3 is equal to 2, and x to the power of 3 is equal to negative 1. So if x to the power of 3 equals 2, then I'm going to take the cube root on both sides. The cube root of x to the power of 3 is x, so I have x is equal to the cube root of 2. So that's one solution of x. And now for x to the power of 3 equals negative 1, again take the cube root on both sides. Cube root of x to the power of 3 is x, cube root of negative 1 is still negative 1. Now to check, I'm going to plug these both in. So let's plug in negative 1. So I have negative 1 to the power of 6 minus negative 1 to the power of 3 is equal to 2. Negative 1 to the power of 6 is 1. So I have 1 minus negative 1, which is equal to 1 plus 1, which is 2. And for the cube root of 3, if I plug in the cube root of 3, well, that's going to be 2 to the power of 1/3 to the power of 6 minus 2 to the power of 1/3 to the power of 3 is equal to 2, which is 4 minus 2 is equal to 2. 2 is equal to 2. So these two solutions are right. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 5 to the power of x is equal to 7. Now, what I'm first going to do is I'm going to take the log on both sides. So log 5 to the power of x is equal to log 7. Now, an important property of logarithms is, let's say we have log a to the power of b. The power property of logarithms states that we can actually move this exponent here, b, to the front of the logarithm. So then this would equal b times log a. So in this case, log 5 to the power of x, we're actually going to move the x to the front of the logarithm, because think of x as b. So now this is going to equal 5, or sorry, not 5, x times log 5 is equal to log 7. Now we want to isolate x, so I'm going to divide both sides by log 5 to move it to our right hand side. So now these two cancel out, and I'm left with x is equal to log 7 over log 5, and log 7, this is equal to approximately 0.8451, and log 5, this is equal to approximately 0.6990. So now we have 0.8451 over 0.6990. And now this is equal to 1.2090. So this is our answer.